Hello, so this presentation is about nitroglycerin and how it's found within nature. Alright, so this is the chemical structure of nitroglycerin. I made it on Chem Sketch, that's why it may be a little bit uneven, but it's basically three nitrogens double bonded to oxygen as well as, it's three bonded to three oxygens. One's a double bond, another one is charged, and it's all connected within this structure. All right. And then natural source. So nitroglycerin is derived from glycerol, otherwise known as glycerin, a common biological molecule from which triglycerides, fats, and oils are all constructed. So basically, nitroglycerin is not found in nature naturally because it's too volatile of a substance. It was first lab produced by an Italian scientist. Anyway, so the main component is going to be glycerol or glycerin. It's either way. This is going to be probably one of the more common biological molecules where it's basically takes the form of fats. So triglyceride fats and oils. One example would be animal fats or maybe some soybeans, any sort of plant or animal fat. Nitroglycerin itself is a laboratory-made component that is a mixture of acids and glycerol. So glycerol is the natural component that is primarily obtained as a co-product of fatty acids, fatty esters, or soaps from oils and fats. Glycerin is a pretty common ingredient in a lot of soaps, like the melt and pour soaps. So it's pretty common, and you can derive it out of any of those processes. And then so some of the primary uses for nitroglycerin. So it's most famous probably for being known as the main ingredient in dynamite. So dynamite is basically just nitroglycerin stabilized by some sort of earth. So usually it's clay, it can be like silica, either way, and it's molded into sticks. It was refined by Alfred Nobel. It was first invented by another Italian scientist, but he did not like the invention because he thought it was too dangerous. So Alfred Nobel commercialized it for mining, and most of the credit went to Alfred Nobel. It's also used as a medicine for heart conditions. It's one of the lesser known uses, but it actually is one of the main medicines used to treat angina, which is one of the chest pain diseases. With people with coronary artery disease. So you can put it to tablets and use that for episodes. Extraction and purification. So nitroglycerin, it's nitroglycerin and nitroglycerol. It kind of varies in this text, but it is both the same thing, as well as glycerin and glycerol. Nitroglycerin is a laboratory-made molecule that does not occur in nature because it's too volatile and it would immediately decompose if it did occur. The main component, glycerin, has a lot of uses and is extracted mainly from the plant and animal sources, where it takes the form of triglycerides, example, animal tallow. Sulfuric acid, another ingredient in nitroglycerin, is naturally occurring. One common example is acid rain. But for the nitroglycerin, nitroglycerin, the acid would need to be a much higher concentration than was naturally found in nature. Of course, acid rain is not going to pose any danger for the most part, maybe long-term for plants or something, but not for humans. But the strength that is used in nitroglycerin will be dangerous. The other acid used is nitric acid, which is also going to need to be a much more concentrated acid than is found in nature, although it is found in nature naturally. And then here's the mechanism for laboratory synthesis. So nitroglycerin is made by reacting glycerin with a 1-to-1 mixture of concentrated sulfuric and nitric acid. The addition of glycerin to the acid mixture creates an exothermic reaction that can result in a runaway reaction. Glycerin must be added slowly to ensure that the explosive reaction does not occur. This is a pretty common thing. In the development of nitroglycerin, there has been a lot of deaths because if glycerin is added too quickly, it will cause the entire the entire experiment to explode. It has happened. This is a model of the reaction and the laboratory synthesis. And it's reacted with nitric and sulfuric acid. And on the left is, of course, the glycerin molecule, and on the right is, of course, the nitroglycerin molecule. And here are the references. All right. Have a good day.